Welcome to Wildcat Science with Mrs. Helgo. This is chemistry and we're doing chapter 6, Elements in the Periodic Table, and this is 6.2, Properties of Groups of Elements, part 2. Previously on part 1, we talked about the S block elements. We talked about that elements are periodic, and then like I said, the S block elements, which includes hydrogen and the alkali metals. And we know that they have one valence electron and make +1 ions. They're extremely reactive, and we know that they are hydrogen. The ones you need to know are hydrogen, lithium, sodium, and potassium. Then we were looking at why they make +1 ions and why they form a 2-to-1 ratio with oxygen and a 1-to-1 ratio with chlorine. Then we looked at our alkaline earth metals, group 2, and we know that they have 2 valence electrons and they make +2 ions, and that they are reactive, not very, just very reactive. And the ones you need to know are beryllium, and then calcium, and magnesium. And we looked at why they make +2 ions, and that they go in a 1-to-1 ratio with oxygen and a 1-to-2 ratio with chlorine and the halogens. Today we're going to look at the transition metals and the D block, which is also the D block metals. So please write this down. This is groups 3 through 12. And what they all have in common is they all have an outer electron. They all have a valence electron in the D orbital. So these often form +1 or +2 ions, and these are what you think about as metals. They are solid, they are good conductors of heat and electricity, and they aren't so reactive that you can find them in elemental form. So you can find a chunk of copper in a rock. You will never find a chunk of sodium just laying around. It's way too reactive. It would have reacted and formed a compound. And these elements often form more than one compound with the same element. Like iron can form several different compounds with oxygen. Like you could have iron 2 oxide, you could have iron 3 oxide. And another example of this is copper can form 2 different oxides when it reacts with oxygen, CuO, which is copper 2 oxide, and Cu2O, which is copper 1 oxide. Okay, so looking at our different groups, starting off in group 4, which is the second column of the transition metals, the element I need you to know is titanium, capital T, little I. And what I need you to know about that is it is corrosion resistant. So, like reacting and decomposing with oxygen, just kind of like rust is a type of corrosion. It is lightweight and strong. So because of these things, it is great for aerospace, it's great for marine equipment and surgical implants, like in a hip replacement, like a titanium ball to go into the ball and socket joint of your hip. Okay, so skipping one column, going over to group 6, the element I need you to know in that column is chromium, Cr. So chromium is hard, it resists tarnishing, and it's used for chrome plating. So you can use electrolysis and you can electroplate some chrome on top of another metal, and that's called chrome plating. You can mix chromium with steel to make stainless steel. So as you know, it has lots of different applications. Moving right one column, the element I need you to know is manganese, capital M, little n. That is used in industry, so it has a lot of different applications, and it's also found in batteries. And then next up is group 8, and the element I need you to know for that one is iron, and it is Fe, ferrous. It is the 4th most abundant element in Earth's crust. It is important for steel. It makes up, iron is in 90% of the worldwide metal production. So basically it makes up the things of our life. So it's involved in a lot of things. And then skipping one column and going to column 10, there are two in there I would like you to know. There is nickel, Ni, which is used in metal alloys to increase tensile strength and toughness. And tensile strength is how strong it is once it's in a wire. Platinum, Pt, is a precious metal that resists corrosion. Also, it's malleable and ductile, and it's often used in industry, and it's also used in jewelry. So it is what we consider a precious metal. Going right one column, there is copper, Cu. It is malleable, so you could hit it with a hammer and pound it into shape. It is ductile, you can make it into wires, and that's one of its common uses is copper wires for electrical wire, also used in plumbing, a lot of building materials, machines, jewelry. It is very versatile. Also, copper is used in making brass and in making bronze. Both of those are different metal alloys, and a metal alloy is a mixture of metals. Also in group 11 are silver and gold, which we know as precious metals that are used in jewelry. They are also important in electronics because of their properties. And in group 12, the element I need you to know is zinc and mercury. So zinc, Zn, is used to make brass, and galvanized steel is steel with a layer of zinc electroplated out on the outside of it, and that makes it more resistant to corrosion. And then mercury, Hg, is not good, not something you want to have around. It is a biotoxin. It is toxic to living things. It is the only liquid metal. Many of the uses that it used to have quite a few uses, but many of those it's not used for anymore because of its toxicity. Two examples are it was in thermometers, including the thermometers you would put in your mouth, and dental fillings, which obviously are in your mouth. So not always great ideas. All right, so here are our transition metals. Just a reminder, the elements you need to know: titanium, chromium, manganese, iron, nickel, platinum, copper, silver, gold, zinc, and mercury. So looking at their electron configuration, something they all have in common is that they have valence electrons in a d orbital. So you can see iron has 26 electrons. It has its 1s filled, it has 2s filled, 2p filled, 3s filled, 3p filled, it has 4s filled, and then it has 6 electrons in its third d orbital. Silver is very similar: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and then it's 5s. And now this one is group 11, 2 plus 9 is 11, and it has 9 electrons in its d orbital. A fun thing about transition metals is that they have complicated bonding properties, and they can form multiple compounds, multiple different compounds with the same element. For example, iron can form in a 1-to-1 ratio with oxygen. It can form in a 2-to-3 ratio with oxygen. It can form in a 3-to-4 ratio with oxygen. When it's this 2-to-3 ratio, Fe2O3, that is rust. Silver is a little bit more consistent. It forms one compound with oxygen, and that is in a 2-to-1 ratio. So in our next video, we're going to go into groups 13 through 18, and that's our p block elements. We'll see you then. Bye.